Hi, it's Mr. T here. In this series of videos, I'm going to go through how to answer exam questions so that you get the best out of your writing when you're sitting exams. If you find this video useful, don't forget to click a thumbs up, subscribe, and then click that bell for notification if you want to see the next video. Okay, so this video is going to focus on how to answer exam questions on addition polymerization. Specifically, we're going to look at how to draw addition polymers when we start with a monomer. We're going to look how to explain that this is an addition reaction and why it's a polymerization reaction. And we're going to look at practice on explaining what the difference is between the reactivity of the monomers and the reactivity of the polymers. Okay, I hope this helps. Okay, so if you want to go through what the questions I'm answering in this video, you can download these papers from if we use the NCEA website. So into our browser, we just type in NCEA AS9165, 2021 if you want to see this paper, 2022 for the next one, and 2023 for the one after. Okay, let's see if we can answer this question. Refer to the reaction scheme of part A for parts 1 and 2 below. Well, we don't have the reaction scheme, but we can answer this question without it. Compound F can undergo addition polymerization reactions. Here's compound F, and it says draw 3 repeating units of the polymer formed of compound F. So what we have to draw here is what the unit would look like when this has broken its double bond and is joining to the next unit in the chain. What we mean by that is this is an addition polymer, so it's going to undergo an addition reaction to itself. So you can think there are many individual molecules of this, thousands of them, and what they do is the double bond breaks, and then the carbons that were either side of the double bond, these carbons then form new carbon-to-carbon bonds to the adjacent monomers to form a long chain. So the way that I might solve the drawing problem here is I redraw this molecule so that we are centered at the bottom just on the 2 carbons that have the double bond, and then I draw the attached groups or atoms straight vertically up and down, just like this one on the right here. So you can see I've in the first carbon on the left, which is this one here, I've drawn the hydrogen going up and down, and on the one on the right I've drawn the hydrogen going down, this one, and this group here, the CH2, CH3 going up. Now all I need to do is I need to stamp out 3 repeating units of this molecule next to each other with bonds connecting these 2 carbons together, and they'll look like this. And at the end I just put this wee squiggly line to represent a bond that goes to another of the repeating units but keeps going on forever, and on the right hand side exactly the same thing. So this is actually it actually gives us an end point. We've drawn 3 of them, but this bond represents that this chain is going to keep going on for a long time, and this is a correct molecule, and we would use this or we would pick up the achieve mark for this. For this actual question, this achieve mark is necessary to actually get the excellence mark as well. So even though they give you an achieve for having this correct, you cannot get the excellence without having this correct. Okay, so this is the second part of 2021 question 2. Remember, you can get this paper by just putting data on the top right there into your search engine. Compound A cannot undergo addition polymerization. Now the reason for this is compound A only contains single bonds, it's saturated, so it's unreactive, right? It's not going to undergo addition reactions. However, compound F has a double bond, which means it can break the double bond and undergo addition reaction, so it's reactive. Okay, remember it's unsaturated. So we need to explain this in sentences. So we start with compound A. It's saturated, it contains only unreactive bonds, single bonds. Because of this, it's unable to undergo addition reactions. Compound F, unsaturated, has reactive double bonds between carbon 1 and carbon 2, When heated with a catalyst, this double bond will break and more carbon-to-carbon bonds will form to adjacent monomers. Okay, so we're going to say these monomers form long chains of repeating units called polymers. So I kind of covered all of the parts here. So what we have here, the answers, if we mentioned that there was A was saturated or had only single bonds, or F was unsaturated and only had double bonds, we get an achieved point. If we link the saturation to the reactivity, then we get up to the merit grade. So basically for one of the and for both of them, so we'd say, look, the double bond is unsaturated, therefore it's reactive. The single bonds are saturated, so they're unreactive. Let me just, I've got this in the wrong order. If they partially explain addition polymerization, what I've written here, they can get an achieved point. So if they said the double bond breaks and we join them together, achieved. If you explain addition polymerization, the double bond breaks and new bonds are formed between the carbons where the double bond are broken to the adjacent monomers. Okay, that's a merit. If you fully explain everything and we've drawn the polymer correctly from the previous part of the question, we get an excellent. So there are a lot of grades here that we can get. One, which is 2020, the only question to do with polymerization in 2020 was, can you please draw a polymer formed from this reaction? So we take this this molecule. What you'll notice here is there is a double bond. Now what I always do if I am going to draw a polymer from this molecule or this monomer, I always redraw the structure, and I redraw the structure to look like this, so that the double bond is on the bottom, and then I'm going to draw the two atoms or group on the left hand carbon bond up and down, and then I'm going to draw the attachments on the right hand one up and down. So we have CH2, CH2, CH2OH and H. Now the reason I do that, and it makes it so much easier to draw 3 repeating units of this, because all that I do when I draw them is I get rid of the top double bond and I just draw the next one to it with a bond connecting between them. So I'm going to connect here and I'm going to connect here, and it looks like this. So notice I've drawn the CH2, and then I've drawn the right hand of this structure, and then I draw a connecting bond to the next one. On the left and on the right, I've drawn this wee squiggly bond, and that just means this will keep going on to connect to new monomers, okay, or sorry, new repeating units forever and forever. Now when I talk about repeating units, I'm talking about this part here. You can see this is like a stamp. I take one of those and then another one of those and then another one of those, and that would go on for 100 or thousands of these in a repeating chain, and that's what a polymer is. So just drawing this polymer, even though it's very complex, we get the achieved point. But remember, when we looked at how to answer the previous question, we actually need this correctly drawn to get our excellence point, so it actually is really important. Okay, 2023 paper. So this is like 2021. It's a longer question, has 3 parts to it. The first part is, well, let's read this. Polypropylene is a polymer used to make a web-like filters in most N95 and loose fitting surgical face masks. Well filtering out most of the microbes. Air can still pass through. Air can still pass through. So when they're talking about, these are the masks, the COVID masks. Polypropylene is made through addition polymerization of the prop-1N monomer shown below. Cool. We want to draw 3 repeating units for this polymer. Okay. So first thing we do is we redraw this prop-1N as we did in the previous questions. Here it is here. Here's the first carbon, here's the second carbon. Notice I've redrawn it so the hydrogens are vertically up and down, and the CH3 group I've moved to be vertically up, so I can better visualize this unit stamping itself 3 times. So we take away the double bond, and then we form a new bond between this and the next iteration of this molecule, right? So this is what we form. And remember, put the squiggly lines on the left and the right to denote that it goes on for lots and lots of repeating units. And this is our polymer. Why is it called an additional polymer? Well, why are addition reactions called addition reactions? There are 2 things that we need to say. First, has a double bond, and that double bond is broken. Okay, the double bond will break, and the resulting monomers can form 2 new single bonds at the carbons where the double bond broke. So that's what we need to do to say that it is an addition polymerization. The other thing we need to say is, of course, that it's going to form a long chain of repeating units, and this is called a polymer. So if we were getting some grades for this, they would give us an achieve for drawing the correct polymer. But remember, again, if there's going to be an excellence question, they'll expect this to be correct as part of the requirements. And then we're going to describe an addition reaction, so the breaking of the bond and then the forming of new bonds where the bonds were broken. Or describe a polymerization reaction, which is you saying that this unit would form long chains. Okay, so that's how we get the achieved points here. If we fully explain polymerization, that is, you explain how the addition reaction works and that it forms long chains, both bullet points, you get the merit. Right, this part of this question is, it's relatively chemically inert, unreactive. Compare the reactivity of polypropene with its monomer. Right, so we're thinking about propene and polypropene. So polypropene has a double bond. Sorry, not polypropene. Propene has a double bond, and polypropene is only single bonds. So we're going to talk about the reactivity of single bonds compared to double bonds. Single bonds are saturated and unreactive. Double bonds are unsaturated and very reactive because they undergo addition reactions. So polypropene is a saturated molecule containing only single carbon-to-carbon bonds. They are much less reactive compared to the unsaturated double carbon-to-carbon bond present in each propene unit. The unreactive nature of this polymer means it's suitable for material to use in a face mask. Now what it means, if something is unreactive, it means the normal things that it's going to touch in the everyday environment are not going to react with it or break it apart. You don't want a face mask to react with the water that's coming out of your breath or the oils from your skin, and if it does, then it's not going to work. So the reason we want this polymer to be saturated is that it's not going to undergo any addition reactions, because imagine if we did do any addition reactions, it's going to change its structure a little bit. So if we were able to say about it being unreactive and we were able to link it to its use, of course we get an achieved mark. If we do both points, we get a merit. And if we do the whole first part of the previous slide, first part of the section, and we draw the structure correctly, we are going to get the excellence point. So again, you can see this polymerization question is often quite a robust question with lots of grades. Sometimes they don't focus on it and you just have to draw it, but it's always there and it's really important. Hope this has been helpful. Okay, if you've got to this part of the video, you've obviously watched all the examples that I had on those 3 questions. Hopefully this has fortified your understanding of geometric isomers and you are now well prepared to go and attack that exam. Good luck, and if you found this video useful, don't forget to like it, subscribe, and look out for new videos that I might put up by clicking that bell. See you later.